I'm really pleased to continue this session and think about centers and organizations, and to introduce two of our next speakers, both of whom have really thought deeply over the course of their career about centers, about organizations, and how to improve the practice of team science and teamwork, particularly interdisciplinary teamwork, in those settings. I'm really happy to introduce my colleague, Dr. Margaret Palmer, who will be our first presenter. Margaret is the Executive Director of SESYNC, the National Socio-Environmental Synthesis Center, and Distinguished University Professor in the Department of Entomology at the University of Maryland. Margaret is an international expert on the restoration of streams and rivers, and as such, her interdisciplinary research that bridges hydrology and ecology has contributed to testing and extending fundamental theory in marine stream ecosystems and understanding of a variety of interactions truly relevant to not just understanding, but to restoration of these critical ecosystems. Margaret's work has extended not just to the core science, but to deep and substantive interactions at the policy level. She serves as a technical advisor and solution-focused based teams with a real problem-solving aspect dealing with social, legal, and policy implications. She's a fellow of the Ecological Society of America, the American Association for the Advancement of Science, and has been an Aldo Leopold Leadership Fellow and Lilly Program Fellow. As director of SESYNC, Margaret has played an essential and truly catalytic role in center design and evolution. She oversees collaborative cross-disciplinary research groups and works to identify not just data-driven solutions, but a whole variety of different program aspects leading to solutions to environmentally focused problems and helping to inform decisions. Margaret Palmer.
Thank you, John. Thank you, John. I appreciate that. So I'm tasked with giving just a brief sort of case study of a basic academic researcher who leads a major center, and how we went about developing ideas for the center and its design, its organization, and leadership. So a number of years ago, about 9 years ago, the National Science Foundation put out a call for proposals for a National Environmental Synthesis Center. What we proposed, and this involved my fellow leaders, Jim Boyd, who's sitting at the front table, who's an economist, and John Kramer, to his left, who's known for his work as in facilitation and team leading, as well as his science. The three of us, because of our past work, decided that if we were going to do this, we wanted to be bold, which is one of the keys, I think, to getting an award, and that we wanted it to be focused on socio-environmental, not just on environmental problems. And the idea there was, after all environmental problems are social. And so we ended up getting the award. And one thing that's interesting about this award is that while the mission is really focused on solving problems at the interface of people and the environment, balancing both of their needs, we actually were charged with a number of sort of submissions. And that is because to solve these kinds of problems, you have to do highly transdisciplinary work that engages social scientists and natural scientists, as well as individuals from what we call potential knowledge user communities. And so how do we approach doing this? So I should say at the start, it's a large center. We have about 25 staff members, 20 full-time postdocs in residence. We have about 600 visiting scholars a year, and we support about 40 research teams. So it's a pretty complicated operation. So in organizing this and thinking about it, the three of us really focused first on saying, well, what are the hurdles we expect to face? If our goals are to accelerate research in this area, but also to build new teams to help accelerate team formation and build communities, and at the same time, really try and work on helping teams bridge epistemological boundaries. So after many hours discussing, and many days and weeks actually discussing the challenges, the next thing we wanted to do was initiate essentially a process where we enacted our general philosophy, which is if we knew how to do this to really essentially help bolster a brand new scientific enterprise with new people at the table, it would have been done a long time ago. So we went in with a philosophy that what we came to call the center as experiment, where after we identified the challenges, the major challenges we thought we would face, doesn't mean we had identified all of them, many came up later, we then hypothesized solutions. And those solutions were very much part of how the center was organized, how it would be led, what kind of programs we would have, and how we would interact with teams. And so the idea was identify challenges, hypothesize solutions, implement those, and then we used a developmental evaluation approach to rapidly evaluate how those programs and processes, we came to call them, were working. Now, this is more like what a startup might use, and I will say at the outset that this gave us a little bit of heartburn. Not really us, it gave NSF and site visiting teams a little heartburn because they wanted to see a summative kind of assessment. You know, we did do the bean counting that NSF always expects, how many visitors, how interdisciplinary were teams, how many papers published, et cetera, et cetera. But we were very much focused on how are the processes working? Are teams finding it easier to accelerate their process and their progress in research and overcome those serious epistemological, language, all sorts of hurdles when they work with us than without? Are we building capacity? How do we even measure that? When people leave here, are they more able and more well prepared to undertake this kind of transdisciplinary research? This was particularly important for our postdoctoral pool because all of them are in residence. They have what we call collaborating mentors who are anywhere in the world, but they only meet with them face-to-face occasionally, and they could talk to them by phone or Skype weekly. But they are doing independent research at our center, and I should say all of this is synthesis research, and that is research that uses existing data, modeling, computational approaches to test some hypothesis or explore some question, and of course it related to the interaction between people and the environment. So we don't fund research teams to go out and collect new data. So there's a very strong computational component at our center. So some of the challenges we identified in advance were many of the ones we've talked about here in terms of team dynamics, but there were some that were unique to us. So for example, because we wanted to build new communities, we didn't want to just fund teams who had existing collaborations. So we had a requirement that every team we supported, at least 50% of the team could not have worked together previously. Another challenge that's really sort of set us apart is that the complexity and the scope of socio-environmental problems is somewhat unique. These are the kinds of problems that have been mentioned at least twice in this meeting, and they're problems where there's what we like to say is a family of solutions. There's no one solution because different people with different values or people from different organizations have very different ideas about what an outcome should be when you're trying to solve a major environmental problem. At the biggest level, this would be climate change, but of course there's stuff at much smaller scales. There's other issues related to dealing with socio-environmental problems in that, namely, those problems almost always cross scales of time and space, making them hard to study. There's a lot of nonlinear interactions between the components in both social and environmental systems. And then, so the first major challenge was novel teams working in short bursts. They come to the center, get together anywhere from 2 to 4 times a year, over 2 or 3 years, and then they disperse back to their home institutions. So we also had to think about how to design the center facility to maximize interaction. So we really looked at every possible facet that we could use to overcome some of these hurdles. So let me go to the next slide. I guess I have to do this. my last slide. It just is to give you a sense of some of the key components of our structure. So the first thing I'll start with is that our philosophy of leadership was very much like, had some of the attributes Steve described. It was shared leadership. So John and Jim and myself make all the major decisions together. We don't independently make decisions that are of a big nature. We also have distributed leadership. So we have a communications team, we have a computational team, we have a cyber IT team, and we have facilitators and research leaders. So it's essential that this is the top leadership communicates constantly with those groups. If there's anything I can say about running a center like an ERC, you have to really assume it's going to be a full-time job, and that communication requires constant work, and it's, I think, probably the most difficult aspect. And I will freely admit that in my case, I still have a research lab for independent work on the university campus, which means I'm not the best person to always ensure that communication works well. So that's a role that Jonathan Kramer has played. So he's much more engaged in leading the sub-leaders in making sure things are going smoothly, while I tend to be more engaged in the big picture issues. It doesn't mean that I don't get involved in smaller issues. It just means there is some sort of a hierarchy within the system that was necessary to keep it functioning. So to actually test those hypotheses we had, and that coming up with kinds of solutions to try, we created what I'll call two sort of components. Ones are the programs, and those are on the left in the boxes. That means the kinds of things, the kinds of projects that are undertaken, and then you could look very deeply within each of those boxes about what kinds of processes we use to facilitate their success. Examples would be, we don't just support team projects. We found early on we also needed to be proactive and go out and recruit projects, not wait for them to come to us as proposals, in order to make sure some cutting edge areas and were being addressed, and that we were really pushing the envelope. We also recognized that in our community we had problems with computational capacity. And so we set up a very large computational team. These are PhD level statisticians and computational experts who do nothing but work with our team. They're not there to do their own research. Our postdoctoral program, this is an example where we failed and we had to adapt. And that was fundamental also to our philosophy. High flexibility, the whole idea behind sort of hypothesis testing, for, if you want to call it that, about how you organize the center. You evaluate it rapidly with a developmental evaluation process, and then you change. So initially our postdoc process was they submit proposals, they have to include social and environmental elements for their independent research project. There's a peer review panel, et cetera. But after sometime during the second year, we realized, you know, we're supposed to build capacity. If we expect all of our postdoctoral fellows to already understand how to do transdisciplinary work and work at that boundary, we're really only funding those who sort of already get it and already have that. And so we dramatically changed that program. We opened it up so that they don't have to be doing both aspects. But what we did in association with that was to develop a very extensive program that introduces the postdocs to the theoretical lenses and the methods through which some of the core disciplines that are involved in socio-environmental research approach their work. And this was pivotal because the thinking was they have to know enough about the field of anthropology and what ethnographies are, and that they're not just storytelling or quantitative, in order to know if they even need to collaborate with people like that. So that was an example of a rapid iteration. On the right is what we call our process of working with every individual team. And I won't go through all of those boxes. This is something that Jonathan Kramer leads. He is the enabler at our center. And Basically, the idea is, because we're trying to build capacity from the very beginning, we work with teams and we do it throughout the way, focusing on some of the fundamental principles from team science, how to keep them going, how to get them over hurdles, how to enhance the ability of the leaders to do it all themselves. And so this is just a little story about how we have progressed, how we did it. There's lots of ways to organize centers. We sort of took a scientific approach like any other problem we'd done before and said, well, we're not sure the best strategy, so let's try some things, essentially experiment and move forward. I'll just close with saying we did, of course, have other problems besides needing to revamp the postdoc program. We had a lot of confusion over one of our messages which relate to actionable science, particularly with external review panels from NSF who wanted to see us change policy. And that's another story. Actually, Jim's going to talk a little bit later about things like what is reasonable in terms of a level of attribution for what your center does versus other things. We had problems with at least one major staff member. People asked Steve about this and what you do. It actually took us 5 years to get out from under that and to move forward for complex reasons that it is difficult if you have a senior leader in there and you have to move forward. So I'll close with that, and I think we're going to hold questions and move on. John?